Velocity, mass, and impact forces. Changing the time over which a collision happens isn't the only way engineers can design for impact forces. Both the velocity and the mass of an object affect the impact forces involved in a collision. Changing the velocity of the pod on impact. The faster objects are moving when they collide, the more force they experience during the collision. If you can slow an object down, it collides with less force. How can you slow a falling object? Imagine taking two identical pieces of paper, crumpling one into a ball, and then dropping both pieces from the same height. The crumpled piece of paper would have a greater velocity than the flat piece, and would hit the ground much sooner. Both pieces of paper have the same mass, so why does one move faster than the other? The flat piece is more spread out, and more of its surface interacts with the air as it falls. It slows down due to air resistance, a type of friction caused by air molecules. Just as friction slows objects down as they move across surfaces, air resistance slows objects down as they fall through the air. The more of the surface of the object interacts with air molecules as it falls, the more air resistance it experiences. Engineers can slow falling objects and reduce impact forces on objects by increasing the amount of the object's surfaces that experience air resistance. However, this doesn't work in space. In places where there are no air molecules, like in space, there is no air resistance. Changing the mass of the supply pod. Objects with more mass collide with more force. Imagine that a soccer ball rolls off a table and falls on your foot. Next, imagine a bowling ball rolls off that same table and falls on your other foot. You will feel that there is much more impact force with the bowling ball. Ouch! Many people think that the bowling ball must be moving faster than the soccer ball because it hits your foot harder. However, since the objects are about the same size and shape, they experience a similar amount of air resistance as they fall. They fall at the same velocity. In fact, this is true for any two objects, no matter what their mass, if air resistance is not a big factor. When dropped from the same height, they will land at the same time. Changing an object's mass does not change the speed at which it falls, it only affects the impact force. Designing for impact forces. Our pod designs are a bit like that soccer ball and bowling ball. In each test, the shell is the same size, but the contents have a different mass. The contents of the shell and the materials used to build it determine its mass, but do not change its velocity on impact. In order to change velocity, the pod would need something that increases the surface that interacts with the air, like a parachute or flaps. Engineers can decrease the impact forces by decreasing the mass of the pod, decreasing the velocity of the pod, and increasing the time over which the collision occurs.